All right, welcome to Cyber Tech Risk Talks, and I'm your host, Bryan Lee. And today we are very happy to have two industry experts, Shawn Riley and Tahseen Shabab, to join us to talk about this very interesting topic, AI in cybersecurity. And we want to do a little bit in-depth talk because there's a lot of other talks right now, really at a little bit high level. But we have those two experts. We want to give you some their insights, valuable insights, draw from years of experience and expertise. So at the beginning, probably we can ask them to do a quick introduction. So Shawn, can you start first?
Sure. Thank you for having me, Bryan. My name is Shawn Riley. I'm the Chief Visionary Officer for DarkLight. DarkLight is an artificial intelligence company that builds AI expert systems in areas like cyber defense. And I've been in the cybersecurity field since the early 90s. So I've gone through almost 3 decades now of experience working in the trenches and seeing different solutions come and go, and really saw kind of pieces of the AI systems as they were starting to emerge over the years. So thank you for having me on this talk today.
Amazing. Thank you very much, Shawn. So back to you, Tahseen.
Thank you very much, Bryan. Thank you for hosting the show, and it's an honor for me to share the stage with an industry veteran like Shawn. I'm Tahseen Shabab. I'm the founder of Bibu Labs. We're a University of Waterloo cybersecurity startup, and we're leveraging some AI modules to solve challenging problems within security operations centers and MDRs. We have 3 professors from the University of Waterloo on board, one as our chief scientist, and we have 2 advisors as well. So I graduated from the University of Waterloo in electrical engineering in 2013, and since then I've been a cybersecurity consultant for some very large clients like IBM, a large bank in Canada, a Fortune 60 telecommunication firm in the US, a North American government, and more. And I was also the lead developer of an application security cloud solution called AppScan Source on Cloud, which has been used by many Fortune 500 firms. Again, I'm really impressed by Shawn's expertise, and I look forward to giving a different spectrum of the problem and as to how we have been seeing it involved with academia as well as the industry. Thank you.
Wonderful. So my name is Bryan. I also do a quick introduction about myself. So my name is Bryan Lee. I'm the founder of Cyber Tech and Risk, which is a platform for cyber people care about cyber technology risk or security. So to get some fresh ideas and advance their career and also expand personal or business network. So this Cyber Tech and Risk online talks is we interview industry leaders like you guys. So also I'm really admire you too, because you all have coming from the industry, have a really good experience on that one. So AI is very hot, as we all know, right? And the cybersecurity also very hot. And when you combine those two things together, makes that even harder. But AI has been in industry for a long time. Although cybersecurity recently become the hot topic, but AI is there in a long time. So from history point of view, or the evolution of AI, maybe some of you can give us some idea about where it's from and what it looks like right now. Maybe Shawn, you start.
So yeah, thank you. I would like to, the history of AI is like a really, really big topic, and I thought that maybe we could frame kind of the history of AI within a cybersecurity, look at how cybersecurity kind of evolved and where AI started to come along and where we saw bits and pieces of it. And so, if I look at the last, couple decades, if I start with framing this in some terms that the industry is used to. So if we think about the NIST cybersecurity framework, it really focuses in on things like identify, protect, detect, respond, and recover. And I think that's a really good way to frame kind of the evolution or the history of cybersecurity and the solutions that we had. And in the 1980s, most of the tools and solutions that we had focused in on identify. And they were really, identify my assets, identify the configurations that were on there. When we moved into the 90s, we started to focus a lot on protection, and defense in depth was the big motto back then. and we were installing solutions like antivirus and firewalls. We were working on secure configurations. And, in both the 80s and the 90s, the makeup of the cybersecurity organization was 100% security engineering. And then, when we got into the 2000s, we shifted over from a protect focus to a detect focus. And we started installing things like IDS systems. We realized that we had to, really go through all those audit logs that we're collecting. And so you saw solutions like security information event management systems, or SIMs, come along, and you saw a change in the makeup of the personnel inside the cybersecurity organization go from 100% security engineering to about 90% security engineers, 10% security science, where you needed to bring in those analysts and the investigators that are focused on making sense of the data that we're collecting. In the 2010s, over this last decade, we shifted from a detect focus to a respond focus. And we saw things like incident response systems, we saw threat intelligence platforms, we saw threat hunting, endpoint detection and response, the whole rise of the SOAR, the security orchestration and automation segment. And I think that as we move into the future, into the 2020s, that we're going to focus more on recover. How do I recover? And even more focus on resiliency, which is kind of defined as the ability to recover quickly. And if you think about over the last couple decades, we've started to, apply different solutions. And in fact, if you think about expert systems in the 80s and 90s were primarily a collection of rules, if then else type rules. And when we saw security information event management systems come out in the 2000s, I believe that these were really modeled after some of the advantages of early expert systems, where you were able to build rules, apply your human knowledge in those rules to do different types of detections. And I think that, even if you look at signatures, when those came out, and even firewall rules, those were attempts by the humans to capture knowledge within those and apply it, but it didn't have the AI component yet. Just like in the 2000s, we saw statistical summaries also come up, and where you'd get a data set, and rather than having to dig through the data set, you could start off with the kind of a statistical summary of the data set and counts of all the different types of things in the data. And that allowed you to kind of narrow in your focus. And I believe that both of those, kind of the statistical side, kind of grew up and led to more application of different types of algorithms that really focused in on probabilistic reasoning that supported machine learning and deep learning. And, it's also interesting, I think, that, when you think about how expert systems have evolved, I mentioned, in the 80s and 90s, they were primarily a collection of rules. And I think it's important to note that, over the 2000s, you saw the rise of semantic web standards. And semantic web standards like OWL and RDF, they really formalized, or I should say standardized, how you can apply description logic and first order predicate logic. And so over the 2000s and the 2010s, we've seen those semantic web standards mature. And those are actually knowledge representation languages that are used within knowledge engineering to create AI expert systems. And so we've seen that kind of evolution throughout the last couple of decades of technology continuing to advance. And so I think that you're going to see the continued application of mathematics and algorithms to tell us about the data on the data science side. But I think we're also going to see the continued evolution of knowledge engineering to build more advanced expert systems, especially leveraging those standards, standardized description logic and first order predicate logic.
Wow, wonderful. That's I really like what you described. So for a couple of things you mentioned, if I can summarize that. One is you use the NIST cybersecurity framework. Basically tell us the evolution of cyber technology In fact, very interesting. Although NIST says there's 5 stages, the technology actually went through those 5 stages and moving towards the last one. So that's actually very beautiful, kind of related two things together. And also, I can see you also say, okay, how AI can apply to this journey, especially at the early stage of the rule-based, kind of a lot of industry things there, then evolve to expert systems, and how the expert system also can leverage some like a knowledge framework or something like that to apply to the AI domain.
Yes.
Wonderful. All right, so that's a very good insight. So back to you, Tahseen, what do you see from industry point of view? I know you have a lot of interesting experience on that one as well.
So, firstly, thank you, Shawn. I thought that was fascinating. I mean, it's great to hear that history from someone in person, and it adds a lot of context to our conversation. From my standpoint, I stepped into the industry early on in 2012, but then after graduation in 2013. So I was doing my electrical engineering at the University of Waterloo, and during my 3rd year in 2012, I was taking a lot of courses within cybersecurity. And I was also a co-op student at this telecommunications startup in 2012, which got acquired by TELUS. And there I was doing a lot of work with deep packet inspection. So we would model users, the network traffic users, and then there were some statistical analysis which was performed on their users. So we would again go through the UI with different flows, and then we would kind of dive deeper to understand who are the users of our network and whatnot. So those were some of the things we were doing. And again, there was rule-based as well, as Shawn has identified, where you can state that, okay, after certain rules, you can trigger certain defense mechanisms. So those were the things which were already there in 2012, but it really fascinated me, and how scripting could be leveraged to perform a lot more based on those detection mechanisms. There was a hint of automation there as well. So again, these are things which really interested me. So in 2013, I joined IBM's AppScan division. And then we were championing a cloud security solution to perform static analysis on source code. And even then, we were doing some machine learning there to reduce false positives or reduce noise, so that we could curate the most important findings for our clients. And then in 2015, I jumped into IBM's consulting practice, where I was working with many large clients, and I've noticed I've noticed cybersecurity from various different spectrums. One would be I was tuning this IPS or IDS for a client in North America, and we were in the US, and we're using a complete data-centric approach. Because, for instance, if you look at the SIM tool, again, you have these sensors, could be your IPS, IDS firewalls and whatnot, but we want to tune these. We had to tune these sensors so that you're only sending meaningful information to the SIM tool, which would aggregate all your data sources. So we're taking a data-centric approach, and we noticed many interesting things. One would be like there was a mechanism for performing machine learning to defend against certain attacks. But then the problem was clients weren't using them, because what happens is with a high throughput environment, even a little bit of error could mean a lot. Like say you could flood the system either with false positives, or if you're blocking a true legitimate user flow, then it could lead to some legal problems based on the client agreements this company had. So in which case they just shut down the machine learning system. And again, these are the things which really intrigued me to dive deeper into what's happening. And also I was one of 4 consultants to lead a tactical risk assessment, the first tactical risk assessment suite for one of the largest banks in North America, in which case, again, we had access to a lot of data, vulnerability data. You have your threat intelligence and whatnot, and then I was the only developer who aggregated all those data flows into a solution to provide a risk score for our client. We were using NIST. I mean, we could be using NIST and COVID and a bunch of other frameworks. So that's where I got a better understanding of the different data which could be leveraged, and yeah, that kind of intrigued my curiosity. And then I started working with professors on doing some research on machine learning, deep learning, and reinforcement learning to mitigate some of the challenges. And for me, one of the biggest problems is like analysts are flooded by alerts. There's tons of alerts, and then the problem of false positives are a big problem as well. So our view is not from a detection standpoint, but from a human-computer interaction standpoint. So the solution we are building lies in between your SIM solution as well as your analysts. So our objective is to optimize the performance of analysts by having a layer where we could help them visualize some of their things they need, some of the data points they need the most, as well as understand these analysts so that we can reduce their stress and improve their work.
All right. Wow. So Tahseen, what I can see, although I already know quite a lot about you, but again, from your experience, you kind of starting from cybersecurity, right? So you're from the cybersecurity industry first, like IBM experience, working at a consulting firm. Then you discover a lot of pain, right? So you discover a lot of problem in this field. So you kind of have a first-hand experience from the security analyst point of view, like operation point of view, what kind of pain you experience. Then from your journey, you discover from your entrepreneur journey, of course, well, you discover how to maybe leverage AI or machine learning or whatever technologies can help to solve those kind of problems. So that's kind of your journey from there. I can see a lot of inside experience and first-hand experience directly facing those problems.
Thank you, Bryan. And to add to Shawn's point, like a lot of the problems Shawn mentioned actually lies within application security as well. Again, for instance, when we have in a DevSecOps environment, for instance, you have scanners, you have a large number of alerts, but then as analysts, we have to individually go through them and add our own contextual knowledge to these alerts as well. Could be your vulnerabilities, okay, yeah, and then we mitigate issues. So there's still, that challenge lies not only within security operations centers, but it lies within various other segments.
Mm-hmm. All right.
And I would imagine that a lot of your human-computer interaction is helping the analysts get the most out of the data sets that they're working with.
Yes, that's one of our research areas as well. Thank you.
Wonderful. So I guess industry has a lot of hypes, right? So of course, any new technology or emerging technology, people want to use that to all kinds of purposes, especially for AI. A lot of people consider AI is the ultimate solution, right? So people often said, okay, I went to a lot of conferences. So some people just comment out, say, okay, the answer is AI. And regardless what the question is. So the answer is AI. So kind of like the hype for this. But cybersecurity also, we all know, recently, there's not all recently, actually, we have been seeing so many breaching news, big or small. So it feels like the problem with this industry become worse and worse. That's just a general feeling a lot of people have. So applying AI to cybersecurity sounds like a reasonable approach, right? So of course, we have so many data. We want to using AI to do that. But you two are the like industry experts. So what do you see from insiders' point of view? What kind of major challenges or strategy you think when we're applying to AI we need to pay attention to?
So I think it's important that to point out to the viewers that Tahseen is primarily going to address kind of the data science derived AI side and the problems that we're seeing over there, and I'll address primarily the knowledge engineering derived AI and the problems that we're seeing. So that way the viewers can expect to have kind of equal coverage of both of the major fields of artificial intelligence being applied within cybersecurity today.
Okay. So Shawn, you mentioned the two terminology here. One is knowledge-driven.
It's knowledge engineering derived AI, which means that it's the field of knowledge engineering that builds this type of AI. So if you went to school, you would get a degree in knowledge engineering, which is generally part of the information sciences degree path, as opposed to a data science degree, which focuses on data science derived AI like machine learning and deep learning.
Okay. So I guess that's the focus, the difference of the focus, right? So one is more focused on the industry specific knowledge, in this case, cybersecurity or framework. Another is to focus on the data itself, try to generalize the rules from data. So that's a data science-driven AI.
Correct. If you think about data science and data science derived AI, it's really to tell you about the patterns in the data and to do that for things like prediction and classification and clustering, but it's entirely focused on the data set that it's applied on. Whereas knowledge engineering is really about how do I organize human knowledge and integrate information coming from different data silos together, along with other knowledge such as frameworks or regulations that would give me knowledge about how to apply or interpret the information that I'm getting from my data silos.
Okay, wonderful. And Tahseen, since there are so many terms in the AI, you are in the AI field. So there's a machine learning, there's what's a reinforcement learning, what kind of learning there. So with what Shawn described about knowledge engineering driven AI and what's that called, the data science driven AI. So where's machine learning? How they related to it? Maybe you can give us some explanations.
So yeah, for sure. So we can talk about the broad context of AI. And now there are a lot of different ways people interpret AI, but for me, from an academic standpoint, like your machine learning, statistical model analysis, these are all a subset of the broad AI, the broad artificial intelligence. Now, for instance, one would be reinforcement learning, which is something I'm really, really interested in. We have a professor from Waterloo. She was doing her sabbatical. She was at DeepMind for some time. So with reinforcement learning, what you're doing is you basically have an agent, and your agent understands the environment and basically interacts with the environment and understands feedback from the environment and optimizes certain conditions. So in essence, so what's happening is it's actually learning new knowledge based on interaction. That's a very different than your statistical analysis, where again you have data and perhaps you're doing some clustering to kind of based on statistical patterns. And so that's one aspect. And deep learning, again, is the recent boom which has been happening over the past, which has got a lot of light over the past 8 years. So in which case with deep learning, again, what you're doing is you're training these neural networks so that again you're on a high level, you're getting understanding these complex patterns, and then perhaps you're doing some kind of inference. So that's on a very high level. It's all data driven. You need the data in order to perform deep learning. You need the data in order to perform, say, some kind of statistical analysis. And with reinforcement learning, again, you need that interaction. So again, you need to have that you want to ideally have that real-time environment where you can interact with some environment to optimize a certain condition and make decisions.
Okay. All right, cool.